Welcome back, my friends. We are back here to build yet another interesting activity for the YByte Python curriculum available at www.ybyte.in. In this particular project, we are going to build a card game called War. Now, there are so many different types of games that people play with playing cards. During social gatherings, during festivals, while they meet their friends, and so on and so forth. These games involve a combination of strategy, thinking, and luck, and that's why they are so interesting, so popular. It turns out that building these games as programming projects is also equally interesting because it gives us really good opportunity to practice our programming concepts and skills. With that spirit, we are going to build this game called War. Now, War is a very simple game, involves only luck, but it's interesting anyway. In building this project, we are going to learn a bunch of new programming concepts and also practice list manipulations. So first, let's see this game being played with our computer, and then we'll see what are the learning objectives before we start building this in a step-by-step manner. Like I said, this is a game that involves only luck played between, let's say, at least two players. So here we are playing, let's say, between the player and the computer. Really, both are the same, but both are being emulated by the computer. But we have a notion that there's a computer, there's a player. This is played with a regular 52 cards deck. So notice the unshuffled deck would be club of say 2, 3, 4 until club, ace of clubs, diamonds, hearts, and spades. Now we shuffle these decks before we play this card. So the shuffling mixes up the cards. We play a toss. Now in this case, computer has won the toss. It plays first. Both players and the computer play out a card. Notice the player's card is a jack. Computer's card is a 5. Now in this version right now, we are going to ignore the color, ignore the suit, which means that I just look at the card value. Player wins because the player has a bigger card, and the player wins. Player ends up getting one card extra from the computer. Now basically both have divided the cards equally, so 26 to start with. Player won, and hence its cards are now 27. This time round, notice player has lost because computer has put out an ace. Player has a 7, computer wins, and their cards become equal. Player wins, computer wins. So this continues. Let's see if we can get. Okay, so player wins. We play this for certain rounds. The game was drawn because at the end of this game, there are exactly 26 cards for both of them. Now it turns out that there is another situation in this game where when the player and the computer play out a card, both of them end up with exactly the equal card. For example, here, player has played 4 of clubs, computer has played 4 of hearts, 4 and 4 are being equal. This is what we call war. Now what happens in the war is that both of them have to shell out extra cards and then play out one more card. Now we are going to see this in more detail later on, but notice what will happen is uh, they shelled out more cards, so both of them sent out say 3 cards and played an extra card, so both were left 19. Amazingly, there is one again war happening here because this time round both have played 5. So war again happens. Again, both shell out more cards, but finally player has won it. Now, since the player has won it, if I see in the next move, player will have a lot of cards. Basically, from 15 cards, player went to 32. Now, we're going to look at all this mathematics a little bit later, how this all works out. But notice during the war, the cards on the table were increasing because both the players were contributing cards to the table cards. Finally, player wins and player took a lot of cards. And I think this game, player has an upper edge. Player has 34 cards at the end of the game and computer has 18 cards. Right now we are going to see, like I said, in detail how we are how this whole thing is going on as we go along, but this is how broadly the game works. Quite interesting, lot of logic. So now in terms of the learning objectives from this game, well, we are going to work with lists extensively. In fact, this project will require us to manipulate lists again. Specifically, we look at using this method called the extend, which adds multiple elements to a list, and we'll also look at how to delete items from a list because the player card, the computer card, the table card are all lists that we are using and they'll interact with each other, as you'll see later on. We'll look at multiple methods to delete items from a list, and that is quite interesting. We'll look at the random module more closely. We'll use two specific functions, specifically let's say random to shuffle and random to choice, to pick out these cards. And of course, all of this will get embedded in a bunch of programming logic. The game rules are actually simple, but programming this to build is not trivial. We will get extremely good practice. Now, the most interesting part of this code from this point of view is that we end up with a nested while loop in this project because there are really two loops that are running in this. We'll see one inner loop and one outer loop, both of them implemented through a while loop, and interaction between these loops is very interesting. We'll look at all of this in more detail in a step-by-step manner as we go along. But in general, if you find that building activities to learn programming is something that excites you, do look at our website because we have many, many, many such activities that you can learn programming with. Take care. Thank you so much. Bye bye.